Okay, so good day. We are going to plot a graph of distance against time and of distance against time squared. So I'm going to show you how to do this and you could plot along with me. Okay? All right, so first of all, we have our information right here. We can use this information. Let's get started. Here we have this graph paper. And I'm going to plot in landscape. So you could either plot in landscape or you could plot in portrait. Make sure if you have graph paper with holes in it, that the holes are on the left hand side. Okay? So you could plot like this or you could plot like this. But for the purposes of this video, I would like to plot in landscape. Okay? Alright, so I have the values here. But before we go into the values and all that, I'm going to draw my X and Y axis. Okay. So you need a ruler and you need a pencil, but I'll use a marker so that you can see the points and you can see the lines and everything. So the first line I'm going to draw, the first axis I'm going to draw is the X axis, which is horizontal. And you want to draw it along the line. You could draw it along any blue line, but it's best to have proper spacing. So I'm going to draw it on the margin here. And I just put on a little extra piece so I can draw my arrow. Okay, so that's our X-axis. And then I'm going to draw my Y-axis now, which is the line that's vertical. Again, I'm going to draw it on the margin. Give enough room. Okay. All right, so we have our X and our Y. I'm going to put my arrow right here. Okay. So when we look at the numbers, we see here that time goes from 0 to 5. So I know I'm going to write my range. My range goes from 0 to 5 because I need to know how to calibrate my graph. And I know from a distance, my range goes from 0 to 50. Right? 0 to 50, 0 to 5. So I know how I'm going to calibrate my graph. The questions tell us that we need to draw a graph of distance against time. So we know that this is our Y against our X. Okay, this is physics. So our Y against our X. So our distance goes from 0 to 50. So on the Y-axis, we need to label it distance. And we use S as the unit for distance, as the symbol for distance, sorry. And then we're going to put our units in brackets, which is meters. And we know for our X-axis, we'll write time. T is used as a symbol, and the unit for time here is seconds, okay? So we need to label our axes. So this is our Y-axis, and this is our X-axis. And we know for time, it goes from 0 to 5. So usually you want to have a nice wide graph. So since it's going from 0 to 5, we don't want to say, oh, every 5 spaces we're going to put maybe 1. We also need to consider our multiples. So I'm going to put 0 here. That's where our graph intersects. And so our multiple for this, I would suggest that we use 1. So I would say every 4 spaces could be 5. So I know, let's write it out. So I know every 4 big boxes are every 20 spaces. So I say 5, 10, 15, 20. That'll be 1. 5, 10, 15, 20. And that'll be 2. So if you count in between, you see these little small spaces? That's 5. and I'm just looking at the boxes as it's like this box right here. That's my 1. So that's 2 and then 4. 1, 2, 3, 4. And that'll be 3, 1, 2, 3, 4. That'll be 4. 1, 2, 3, 4. That'll be 5. So we've taken up a good amount of space on the graph. I'm happy about that. And we could even add 6 to this. If you have a graph paper like this, you realize that you have some darker lines, and those darker lines will represent every 10 spaces. But this graph is kind of funny because it has like this little space and then 10 spaces here. So be careful. Okay, so I'm gonna number these now. 1, 2, 3, and 4. Right? So yay, this is our time axis. Now for our distance axis, remember it goes from 0 to 50. So we're gonna have to use a different multiple going up there. So if we look, we could see we could maybe go, maybe you could think about every 10 spaces you do increments of 10, right? Let's see if we could hold 50 every 10 spaces. 10, 20, 30, 40, 50. We can do it like that. Let's see, because this is going to be short. So let's see if we can do we can do increments of 5 every 10 spaces now. 5, 10, 15, 20, 25. It won't work because more than half of this side is on 25 and we need to reach to 50. So if it's a 25, 30, 35, 40, 45, we see we can't get to 50 at the end of the graph. So we will definitely have to use increments of 10 instead of 5 every 10 spaces. This is 5 spaces, this is 10. So it's 10, 20, 30, 40, 50, and we just keep going. 60, 70, 80, 90. And we put in our multiples now. So this is 10, 20, 30, 40, 50, 60, 70, 80, and 90. Awesome. All right, so now that we have calibrated both sides with sensible multiples, we could now start plotting. But before we plot, we also need to know what the space is, how much each space will be equal to in here. So how can we calculate that? Well, for time, we don't really need to do it because all of the numbers are gonna end up on what we have here, but we can still work it out. So to work out what each point in between here is equal to, we simply subtract the smaller number from the larger number within that side. And since the spacing is equal, all spaces will be equal to the same thing. Okay, so if we say in between here we have 0 and 1, so we say this space will be 1 minus 0, and we divide by 20 because it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this will be 1 divided by 20. So each space will be equal to 1 divided by 20. Okay, so 1 divided by 20 is equal to 0.05. So each small space is equal to 0.05. And then with that, you just keep adding 0.05. So this one would be 0.1. Because you add 0.05. So you get 0.1. And in this space would be 0. What do you think? 0.15. And in this space would be 0.2. Okay, and you just keep adding, going across, and you will get the number here. In between here, this one will be easier because we don't like to use decimals a lot. But if you want to figure out what one space is, you would say, again, 10 minus 0 divided by the space. Sorry. 10 minus 0 divided by the spaces, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that will give us 10 divided by 10. And that would show us that each space is equal to 1. And you just keep adding. And this would be 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so that's how you do it. Now we want to plot. So how do we plot these points? Okay, so the first point we're going to plot, the distance against time is 0. When distance is 0, time is 0. Again, right here, when distance is 0, time is 0. So the first point will be this one right here. That's the first point. The second point shows that when distance is 2 meters, time is 1 second. So look at it. We look for when distance is 2, and distance is on the y-axis. So when distance is 2, which is right here, we said the time was 1 second. So how you do that? To find these points, if you're just beginning, you look at the x-axis, because remember, you look at the y, and it says distance is the y-axis. And we said when the distance is 2 meters, then the time, we just come across, draw your line across. You can draw it as long as you want. And the time is 1. This is the time right here, 1. That's where they intersect. You see where the lines intersect here? That's where you put your point. So when the distance is 2 meters coming across and the time is 1, so you want to look for 2 on the y-axis and 1 on the x, and when they intersect at this point, that is where you plot your point. So I'm going to plot all my points in pencil first because I don't want the marker to dry out, and then I'm going to plot them over with the marker. So that's our first point there. So again, when the distance, so we did this point and we did this point. So now we're looking for when the distance is 8 and the time is 2 seconds, okay? So again, we look for 8, and we know that each point, each space over here is 1. So this is 2. We know this is 5. Okay, so this is 3, 4, 5, 6, 7, 8. So when the distance is 8, right, this is 8 right here. When the distance is 8, and this is just for if you're beginning or don't understand, and this is 8, and the time is 2. See, the time is 2 right here. This is our point here. So you want to make a point and then make it nice and neat, and then you draw a circle around it. And since we know all the numbers, like the time when it's 3 and 4 and 5, we know the numbers are here. We don't have to. So we know when the time is 3, the distance is 18. So we know that 18 will be under 20. This is 19, this is 18. So going across here. So going across, this is 18. And we know 3, as we can see. This is 18 here. And this is 3. Okay. So once we find 18 going across and the coincide here, that's our next point. And then when the time is 4, the distance is 32. When the time is 4, the distance is 32. So let's move on up. So 4. And we know the distance is going to be somewhere over here. It's 31, 32. Take your ruler going across at 32. And we see 4 is right here. When we come up, you see 4 is here. So if I draw my line going across, right? And then if I draw this line going up, this is at the coincide right here. Right here. And then we see time is 5 seconds, the distance is 50. Alright. So we see here, somewhere here. So if you want, you could draw your line going right across. Make sure the line is on top of the line that is there. So learn how to put your ruler next to the line. So you don't want your line to fall underneath the line, because that wouldn't be the correct point. You want it on top of the line that's actually attached to 50. If this is 50, you put it on the 50 line going across. And then we look for number 5. Right here we see 5. Right here. And we see where the line coincides right here. And so our 50 mark is here, and we circle it. Okay. So taking my marker, I would now make it so that you can see it. Nice. Okay, this is a curve, by the way. So this is a curved graph. It's not a best fit line graph. So this one is one where we'll connect the points. Okay, and I would do that in I try my best in a freehand way. Right, so you will connect the points like that. But when you're done doing your graph, you need to give it a title. And you can give it a title as simple as this: graph showing distance versus time. Or you could show a graph showing how an object move over a certain distance over a certain time. So you can give it titles like that. I'm going to go very simple and say graph showing the distance an object moved over 5 seconds. Right? So something like that would be nice. All right, so that would be the end of this graph. Okay, so the next question was that you should draw. So let me show you the graph again before I put it away. This is your graph. Nice. You have your titles on each axis. You have your increments, equal increments. You're supposed to always have equal increments. So if this is 10, this should be 10, and this should be 10, this should be 10. Not 10, then 5. So you have to make sure. And then your multiples should also make sense. So if this is 10, you're increasing by 10 every time. You show that, right? So same thing down here. You have 20 spaces. Every 20 spaces equal to 1 unit. Okay, so you don't change up, because if you have a different unit here, your graph is not going to be correct. Okay. Now for the next question, it says draw graph of distance against time squared. So this is basically telling us to take the values of t. Okay. Take the values of t and square it. So now this, we're dealing with time squared. And we're going to put here t squared. And therefore, if we're using time squared, our unit will be in seconds squared. Okay. So all you have to do is take the number here and multiply it by itself. That's what I mean by squared. So this would be 0 squared equal to 0. So this is what we're looking at. 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. And we have 4 squared equal to 16. 5 squared equal to 25. So now our range has changed from 0 to 5 to now 0 to 25. Okay, that's our range. And we'll be using now, we'll be plotting distance. This will be our y, and this is now our new x. So I already went ahead and made a graph, and I put our units. As you can see here, it's different. It's a little bit different now. So I did every 5 spaces, I did a unit of 5. So every 5 spaces, 5. So then therefore I'll keep adding 5 every 5 spaces. It has to be equal. And then for the for the x-axis, I did 1, 2, 3, 4. Every 4 spaces are every 20 spaces. So you could think of it as 4 spaces if you think of the boxes as one. Or you can count the little itty bitty spaces. So I did every 4 spaces for 5. So we could plot now. And look, I made sure to label my axes. So this axis is every 5 spaces is 5, and every 20 spaces is 5. So a little different, as I said. And we're going to plot. So we see here from this that when time is 0, again, distance is 0. So we're going to plot. That's our first point. And then it says when time is 1, our distance is 2. So we look and we check to see where 1 is. All right. So now again, now see our dynamics have changed. We have to now figure out what 1 is, where 1 is. So by doing that, we have to now do our little calculations. So we see here that we have 20 spaces, and so therefore we say 5 minus 0. 5 minus 0 divided by 20. And we will get 5 over 20. 5 over 20 is equal to 1 over 4. So therefore, each space is 0.25. Okay, so that's 0.25. So you keep adding 0.25. So this is 0.5, and this will be 0.75. And then this will be 1. So every 4 spaces will be 1. So you see, so this is 1. So 1, 2, 3, 4. This is 2. 1, 2, 3, 4. This is 3. 1, 2, 3, 4. 4. 1, 2, 3, 4, 5. Right. So each space is 0.25. So that's 0.25, and you keep adding 0.25, and I realize that every 4 spaces you're going to get a whole number, which is 1. So I said every 4 spaces will be 1. So so if you go from here 1, you just add 4 spaces and you get 2, and add 4 spaces you get 3. Because then this would be 1.25, 1.5, 1.75, and then 2. You just keep adding 0.25. So now that we know every 4 spaces is 1, we are good to go. So we know that's when time, as you can see, when time is 1, the distance is 2. And then, seeing as how we have every 5 spaces, and we know it's 5 spaces in between here, 1, 2, 3, 4, 5. We don't have to really work it out, but I can show you that each space is equal to 1. So if we have 5 minus 0, 5 minus 0 divided by 5 spaces, you get 5 divided by 5, which is 1. So each space is 1. So now we could proceed. So when distance is 2, okay, which is on this axis here, the time, we're looking at this, is 1. So again, we look for 2 here. So 1, 2, and we know that this is 1 right here. So this is our point. Okay. And when the distance is 8, our time squared is 4. The distance is 8, so every 4, so you know this is 2, 3, 4, 6, 7, 8. So this is 8 right here. So 6, 7, 8. So the distance, when the distance is 8, again, the time is 4. So we have here 8, and we just count up here. 1, 2, 3, 4. That's right under 5. So you could use your ruler again. All right. And you draw a line going straight across in pencil. And then you look for 8. And here's 8. And once you find 8, you put the point where the lines would have met. Okay, so that's how you plot it. So now from this we see when time is 9, when time is 9, or we could go from distance. When the distance is 18 meters, the time is 9. So we look for distance 18, so this is 16, 17, 18. And we look for 9. So 9 will be right here, so this is 8. 1, 2, 3, 4. This is 9. If you look, this is 4 in between here to reach the 10. And so once we find 9, we make a line, and we see where 18, the line 18 is, the intersect, and we put a circle right there. Okay? Okay. And so when the time is 4, when it is 16, the distance is 32. So we look for 32, which is here. Look for 32. And then we look for, 32, which was the distance. So make sure you're gone here, 32. And then what you want to do, so we have 32 here, going right across. And then now we're looking for the time at 16. So to find 16, we know this is 15. So 1, 2, 3, 4. This will be 16. So we take our ruler and move up on the line 16 to where it would intersect at 32. And we just put a circle right there. Okay? And then we soon finish when the distance is 50. Now we have a time of 25. Okay. So we look for 50 on the distance line, on the distance axis. So remember, distance is over here. So we draw a line along 50. And then we look for 25. And we don't have to count because it's there. And we draw a line. So this is where it intersects. So we put our point and we circle. Nice. So it looks like one of these points are a little off. Let me see here. Oh, I did this wrong. It's when the distance is 8, the time is 4. Oh, so you have to be careful. So when the distance is 8, so I did it wrong. So when the distance is 8, so this is 8 right here. So this is 8. So when the distance is 8, so this is 8. The time is 4. So this is 4 right here. Okay. My bad. I hope you saw that mistake. Very good. All right, so now that we have our points, we can see that this is a straight line graph. So sometimes the points might not be directly following each other, but you could tell when there's a straight line graph because they'll be gathered in an area that looks straight in a cluster. But the one before that, you could see that it was clearly a curve. So I want to just let you know that in physics, you either deal with curved graphs or straight line graphs. That's pretty much it. Okay, so now that I've plotted my points, I feel confident. I am going to darken them with the marker so you can see them. Okay, so we have our points. And so when you do a straight line graph, you want to find you're gonna place the line in between the points, and it looks as if these points are run along with each other, so I'll be able to draw my graph. And here's another thing: when you're plotting points, you need to use a pointy or well sharpened pencil. I'm using a marker again so that you can see. So yeah, so you use a pointy or well sharpened pencil. That should be dark enough so that you can see. Now with straight line graphs, not even with curves, but with straight line graphs, we're going to start with that. You need to find the gradient of the graph. And the gradient of the graph usually represents a quantity. In this case, because we have distance against time, and this is our y-axis against our x, we know that we're dealing with speed. A distance line graph, the gradient deals with speed. Now gradient is equal to the change in values of y over the change in values of x. And how we find the gradient? We look for 2 points on the line, and you make sure they cover all the points. You don't want a small range, you want a big range. So my first point, I'm going to try to find it out here, and make sure that whatever point you find, the line goes through an intersection. Like you see how this intersect these lines, so this going through an intersection right here. I'm going to use this point, and then I'm going to probably use this point right here. You don't have to use the same point that I'm using, you can use your own points. So each point, like you see, has an x and a y coordinate. So the point that you plot would have its own x and its own y coordinate. So to find it, you draw a perforated line in pencil from the point, the new point that you plotted. And note well, I didn't use a point and a circle, I use an x. So it'll be different. So this is my y coordinate for this point. So I'll label this point 1. And so this will be my y1 coordinate, which is 60. And as you note, this axis has a unit of meters, so it'll be 60 meters. And then I would carry my perforated point now to the x-axis, because we need to solve it. And make sure you draw the line along the line, don't draw it in between the space. And so as you can see, my x1 value would be 30. And because it's units of seconds, I put my units right there. Okay, now this point is down here. I drew my x a little bit too high. And so this will be my points here. This will be my y2. And you really want to write everything on your graph, because you need to remember, don't just say, oh, this is no. So you look at it and so this is 1, 2, 3. So y2 is 3 meters. And then we come down here. So I can't see too well, but you probably, oh, see it hits here. Yeah, I put my point. So I hit there. And so this is 1, this is 1.25, this is 1.5. So that's my x2, which is 1.5 seconds. Okay, so once we have established our points, now we're going to work out our gradient. And we just have here, we know that the gradient is either y1 minus y2 over x1 minus x2. So remember, it's y over x. Or you could find y2 minus y1 over x2 minus x1. Either which way is fine. So you look at your numbers here, and I'm going to use this one. You could use this one, so you could see if we get the same numbers. So my y1 is 60 meters, and my y2 is 3 meters. Divided by x1. My x1 over here is 30 seconds. And my x2 is 1.5 seconds. Now note well, this could have been your y, this could have been your point 2, and this could have been your point 1. This doesn't have to be your first point. This could be your second point. This could be your first point. So long as if you label this point 2, this should be y2, and this should be x2. And if you label this as point 1, this should be y1, and this should be x1. But let's keep it simple, right? All right, so once we have this, if you do this way, you would have 3m minus 60m, and this would be 1.5 seconds minus 30 seconds. With this one, you're in negative numbers, but they're going to eventually become positive, because the top and bottom numbers will be negative. Okay, so 60 minus 3 is 57 meters, and then we know that 30 minus 1.5 will be 28.5. Okay, or you will get negative 57 meters divided by negative 28.5 seconds, and that's going to give you a positive number. So your answer now would be, if you divide 57 by 28.5, you will get 2. So I got 2, and let's not forget the units, which is meters per second. You will also get 2 for this one. So this gradient tells us that we are looking at speed. So the speed that the object was moving is 2 meters per second squared. Sorry, it doesn't tell us speed, it tells us velocity. Sorry. So these are all seconds squared, and my bad, these are all seconds squared, because this is seconds squared. So if you have meters divided by seconds squared, it tells us acceleration, because that's the unit of acceleration. Okay, so that's the quantity, so it tells us here for the gradient. So you have to be mindful of the units that you're using. You have to label the axes, and you also have to, in the end, give your graph a title. So this would state graph showing how an object accelerates over time. Okay, or what you could write is graph showing distance versus time squared. You could actually write that. Just write simply graph showing distance versus time squared. So you could write this, or you could write graph showing the distance in meters versus time squared in seconds squared. So you could use the top one or the bottom one. Either one will be fine. So I hope this helped you, and good luck.